want to look at the next two worked examples, which are the last sections of the exercises. So question 9 and 10. So these ones here relate to question 9. So it says evaluate here. So evaluate means find probably a final answer. So get it close to a final. If we look at this log equation, let's just use the index form. So 3 to the something equals 9. And we're looking for that something. Okay, 3 to the power of what? That's actually 2. So 3 squared is 9. So the answer there is 2. All right, let's do B. B's asking us for base 9 something equals 3. So if we put that in index form, 9 to the power of something gives us 3. Now we know if we square root 9 we get 3, and hopefully you remember if you take 9 to the power of half root and square root are the same, and 0.5 root is 3. Okay, so the number that you want here is either 0.5 or half, simply because that's what it is there. I sort of tapered off my voice there and said simply because. Don't get this one confused with, well, it is a fractional power, but it's not a negative, it's just fractional. So fractional powers, I'm just going to rewrite that using the fraction form. 9 to the half equals square root 9, and the whole thing equals 3. So we're finding the half root, which is a square root, so we're undoing squaring with that one there. Let's move on to the next one, where we have base 5 and the answer. So 5 to the power of something gives us 1/25. Because the answer or the y value is in a fraction, we need to remember that the power is negative. So if we just eyeball this for a wee bit, see if it comes to our brains. I know 5 squared is 25, but this is 1 over 25. So what I want to put up there is actually -2. Okay, so another way to think of this is 5 to the -2 is 1 over 5 squared, which is 1 over 25. I'm just going to take that back to leave room to do the last one. So our actual answer there was that equals -2 was our final answer. So that's the way to treat those ones that are fractional for the y. We can just try and imagine what it would be for a positive power, and then think of it as a negative power to get it as 1 over. Okay, last one, D. For this set, we have log 8 log base 8 2. So 8 to the something equals 2 for our answer. 2 is smaller than 8, so I think that we need to think about this one a little bit differently. I know that 2 cubed is 8, so how about we cube root 8? Okay, so cube root 8 will be 2. Now that is us, when we cube root 8, we're asking ourselves what times what times what. So what multiplied by itself 3 times gives us 2. So going from this, I can flip around this expression and say that the third power of 8 is 2, and that's exactly the same as saying cube root of 8 is 2. All right, so that's that one there, because we know 2 times 2 times 2 equals 8. So if we cube root 8, we get 2. Here's our last set of examples, and we're putting things together. So let's look at A first. When we look at A, we have 2 log values, same base that we're adding together, and this one here also has a number out in front. So what I'm going to do is pull it back up here, 5 squared, pull it up to the power, so we're getting rid of that 2 for now. log 10 to the 4. It hasn't changed, that 10 is the same base. So what we can do now is do the product rule, 10, 5 squared multiplied by 4. 5 squared is 25 times 4. So we simplify that to log 10 of 100. Have a look. We can go a little bit further to do what the question asks us to do, which is evaluate. So this one here is our base. We're looking for the power that gives us 100, and you should know that it's 2. So this whole thing here is equal to 2. That's the answer, just 2. Okay, so I'm just going to highlight the final answer. Let's do B together. We're still adding. We have the same base and we have 2 different numbers there. So let's pull those together. So we have log base 5, 12.5, and we're going to multiply by the 10 in this one. So log 5 of 125. Once again, we can eyeball this one and look for the power, which raises 5 up to give 125. That equals 3. So I've kind of used algebra there, but the answer to my entire thing is 3. So log 5, 12.5 plus log 5, 10 equals 3 together. How about that? So you've got these ugly things called logs that you probably don't have an appreciation of quite what they mean yet until we turn them around. But when we add that whole thing, we get 3. Okay, let's do C together. We have log 2, and because this one's a subtraction, the bases are the same, we can divide out the numbers. So log 2, 80 divided is 16. And you could leave it there, but remember you're evaluating and not simplifying. So let's see if we can use the index rules to find what that is equal to. Equals what? So the index rules say that that's our base. The thing that it equals is actually our power. And the thing next to it is what the index equation equals 16. So I've just used the log to index rules. 2 to the what is 16. I think 2 2s are 4 and 4 4s are 16. So that one actually equals 4. Okay. So that thing there is an answer of 4 altogether. Okay, let's do the last one. And we have the same base and it's a subtraction. So log base 3, 6 over 54. I know 54 divided by 6 is 9. So that fraction is actually a ninth. So log 3 to the ninth has made the whole thing simpler for us. However, we can do one more step to say 3 to the power of what equals 1/9. Well, you know 3 squared is 9, but we have 1 over 9, so it's not squared, it's -2. So the final answer is -2. Okay, so that's what that equals.